Modern roundabouts are a newer form of traffic control in Minnesota. They are becoming increasingly popular due to their safety, efficiency, and economic benefits. However, there are many misconceptions and misunderstandings that people hear about roundabouts. In this video, we will demonstrate why roundabouts are a viable alternative for intersection traffic control. Myth number 1. Modern roundabouts are not safe for pedestrians and bicycles.
I think they would have a high likelihood of getting hit or trying to intermingle with traffic. Would not be good.
Well, the big advantage that roundabouts offer to pedestrians and bicyclists is low vehicle speeds. All the vehicle speeds are 25 miles per hour or less at the roundabouts and at the crossings. And the other big advantage is that all the sight lines at the crosswalks are much better because all the crossings are at 90 degrees. It makes it much easier for drivers and pedestrians to see each other and to react.
I went to a location within Cottage Grove that has a multi-lane roundabout, and there's a signalized intersection next to it. When I was at the signalized intersection with a group of people waiting to cross, I happened to look at some drivers who were near me, and what they were doing is they were looking at that light. They weren't looking at anything else. They were looking at the light for their chance to go. They weren't really paying attention to pedestrians. They were looking for the light to tell them where to go and when they can go. When you were at the roundabout, one nice thing that I noticed is as the drivers were coming up, they were looking at you. As they enter the roundabout, they have this wide view as they come up to it, and they can see pedestrians.
I can tell you from experience that the intersection in which we're taking the signal out and adding a roundabout has been very difficult for me to cross with my children. So I'm looking forward to having a roundabout where I know that the speeds will be reduced and people will be more aware as they're traveling past.
Modern roundabouts provide several options for cyclists. Novice cyclists can utilize the trails and crosswalks and enjoy the same benefits as pedestrians. Experienced cyclists can ride with traffic inside the roundabout, following the same rules as motorists. Myth number 2. Modern roundabouts cause more crashes.
I think at first they probably cause more just because people don't know a lot about them. People are so used to traffic lights and stuff.
A study by the Insurance Institute for Highway Safety examined 24 modern roundabouts that were converted from stoplights to roundabouts and found a 70% reduction in injury-related crashes and an 89% decrease in fatal crashes. This reduction in crashes is due to the three main safety features of roundabouts: low speeds, gentle crossing angles, and separated traffic flows.
At typical intersections, you've got traffic that are crossing each other. And when you've got that type of crossing, you've got a crossing conflict. So that if a person blows the stop sign or they go through the red light and a person other hits it, it's that type of crash that you'll have. It's a T-bone crash. Whereas at a roundabout, people are going in generally the same direction because the circulatory roadway is going this way. The entering traffic has to go that same direction. So if you do hit, it's going to be a glancing blow as opposed to that T-bone crash that you'll have at a typical intersection.
You know, as a state trooper, we go to crashes every single day, and crashes are caused by driver decisions in almost all situations. When you have a traffic safety device like a roundabout, you're taking away some of those errors that drivers can make. So although we still may see crashes at them, we're going to see less crashes involving fatal or serious injuries. And those are the crashes that, as state troopers, we go to, and it's devastating to families to have to go through that, especially when they know it could have been prevented.
Myth number 3. Modern roundabouts are built too small for trucks and buses.
I don't even know if a semi-truck could make it around that corner, unless it's like an exit to a highway maybe, but...
The curb around the center of the modern roundabout is actually a truck apron. It is designed specifically to allow buses, large trucks, and trucks with trailers to maneuver through the roundabout by allowing the truck's rear wheels to roll onto the truck apron when necessary. The truck apron is not to be used by regular passenger vehicles. It is not a sidewalk, and pedestrians are not allowed in the center island.
Welcome to today's session. It's good to see all of you join us today. It's good to see you. Please confirm whether you can be able to see us, whether you can be able to hear. Please confirm. For those on LinkedIn, someone to confirm whether they can hear the voice. I remember last time we had a challenge with that, and I would like to know whether you can be able to. Can you hear us on LinkedIn? Let me know. Can you hear my voice if you're following on LinkedIn? All right, all right. How about now, Anton? Can you hear the audio from my end? Can you hear my audio? Please let me know.
We can hear it, sir.
Absolutely. Thank you. Thank you for confirming. Thank you for confirming. There is no need. Thank you. There is no need to try to record the session. The session will be recorded. So you don't have to keep trying to record. The session shall be recorded and a recording provided thereafter. The recording will be provided after this. So Dejan, Talk City, you don't have to request to do the audio recording at this point. I shall record the session and share it out on LinkedIn, on YouTube, and also in all our social handles. So we have already confirmed for those who are on Zoom. Now we go to those on LinkedIn. If you're on Zoom, please just stay mute for the entire period of this session. I have planned this session such that we'll be having specified interactive sessions or periods. I will pause at specific times where I will be engaging each and every one of you. So you do not have to unmute your mic, but also these are the ground rules that we'll be using here so that this webinar can be a success. If you have a specific question, please feel free to drop the question in the chat box, or in the comment section if you're following us on LinkedIn, and I will be able to respond to your questions. I'll be able to respond to each and every question that we have. So please let us be able to follow those simple guidelines so that we make sure that this webinar is as informative and educative as planned. Kindly note that if you will be making noise in the session, we will be forced to put you in the waiting room until now you are in a settled place. I understand that you could be joining us while you're on transit. Please take your time, just unmute, listen to us, write down your questions, and I will be able to respond to all of them. So thank you very much one more time for coming here. My name is James Murithi. I am an highway design expert. I currently work for Kenya National Highways Authority. I am also the lead design engineer and instructor at Ronsab. I have been doing this for quite a number of years now, and just in the last 6 months, we've been able to train over 500 engineers from over 10 countries worldwide. So it's good to see you. I can see if you're here, please drop a flag of your country. We are proud nationals. We are patriots. So I would like to know, where are you connecting with us from? Where are you connecting with us from? Where are you connecting with us from? So I'll be looking, yes, the first person is India, that is Dagesh. So welcome to this forum. Welcome Uganda, Daisy. Daisy, you are most welcome. You are most welcome. Mauritius, I know you re-elected your president. That is another one from Vincent Mwezi. I know you. From Uganda. Good to see you. Good to see you. I can see someone from Burkina Faso. Ethiopia, Jonathan, I've been seeing you around. The Zoom is the most audible one. Savia, good to see you from Zimbabwe. Oh my goodness. We are having people. I've seen another one from Nigeria, another one from Abdurrahman, that is from Egypt. Ifwema, that's, oh my. This is Tanzania, Dennis John. Good to see you. Good to see you. I appreciate each and every one of you for creating time to come and enjoy and learn with us. That's Grace Wajiko from Kenya, Paul Mbwana from Tanzania. This is awesome. This is beautiful. This is beautiful. This is beautiful. This is beautiful. I will also be sharing the meeting link with you just in case, and my team, Eric Ruhiye, I know you're here. Tony, I know you're here. Blasius, Wesley, please, Karen, please be able to share the link. This session is gonna be very, very informative. So India, I can see India. The session is already being recorded, so you don't have to request for a recording. I will be able to provide the recording just the same way I provided the link to join the session. So you don't have to worry at all, at all, at all. Just feel comfortable, enjoy what you can learn for now, and also I'll be able to give it. So thank you very much. And today's session is basically centered around geometric design of roundabouts. Geometric design of roundabouts. For most of us who have probably been able to follow me on LinkedIn, for those of you we have been able to interact, you understand that we've been carrying out the geometric design of roads. So we've been able to design a 6-kilometer road project for most of us. And now that we've been able to complete the design of those roads, we now want to go to intersection design. I understand that most of you have been requesting me to carry out trainings on intersection design, but I cannot start on the complex thing first. So we start with the simple things, then we grow together. So that is the model. For this session, we'll be doing the design of a roundabout. Then we'll go to art grade intersections. We already did a T-junction. We are currently doing a roundabout. And then even after that, we'll go to art grade intersections. And then after that, we go to more complex clovers and such types of intersections. And what I want to emphasize on as you continue to learn and master your craft in as a design engineer, it is don't be all over. That is what have structure, start with the basics, then build muscle by muscle. If you wanted to build muscles, you don't just go to the gym and start lifting 150 kgs. You don't do that. You get injured, you'll get discouraged. You start with the basic things. And then as you do that, you build a strong foundation, and then it becomes very, very, very easy for you to grow and develop. That is it. All right. So I would like to hear from you people, and I will be giving one person from each country that I will, if I mention your country, please unmute. And I want to know, what is your perspective and what is your understanding of roundabout design? Do you think they are effective, safe, and worth adopting and constructing into our roads, or they are not? So I'll just get to hear from 1, 2, 3, 4 people, and then we will go. So of course, charity starts at home. So I'll go with one Kenyan. What is your perspective and understanding of roundabout design? So let me get to hear from someone. I do not know who is with us here. So just unmute and take it away. So the mic is open. So please get to hear or get to unmute and share with us. Kenya, One person from Kenya. One person from Uganda. One person from Uganda. Our immediate neighbors. Yes, please.
Good evening to you all.
Good evening, Vincent.
Yeah, so according to me, a roundabout is a type of circular intersection where traffic flow is in a counterclockwise direction around a central island or a hub. It is also known as a traffic circle or a rotary. And a roundabout, it has got typical features like a central island or hub, a circular roadway or a carriageway, a multiple entry and exit points, then a yield point. I guess that's all I can say about roundabouts. Thank you.
Thank you, Vincent. That's a very very concise definition of what a roundabout is, and of course, yes, we are talking about an auxiliary movement of traffic around a central island. So thank you. One more person from Tanzania. One more person from Tanzania. Please represent your country. One person from Tanzania. All right, we don't have one from there. One person from Zimbabwe. Let's go to the southern part. One person from Zimbabwe. All right, fine. So let me go straight. Oh, yes, please. Okay. Take it away, Xavier.
Oh, yeah. I wouldn't want to define a roundabout specifically, but can you hear me?
Yes, I can hear you, sir.
Can you hear me?
Yes, I can hear you.
All right. Maybe not.
All right, your network is quite unstable. Please, your network is quite unstable. Please get to use the chat box and we'll be able to respond. I want to hear from one person from the western side, that is Nigeria. I want to hear from someone in Nigeria. So Xavier, your network is very unstable. So please,
specifically, but they're mostly suggested to be used on more
All right. Sorry, we could not hear you there. So let me hear from someone from Nigeria. I want one more person from Nigeria. One more person from Nigeria. Danson Dungu, you don't have to raise your hand. Please unmute and take it away. Thank you. Danson.
Hey, hello, James.
Hello.
I'm representing Kenya. So I would say roundabouts are crucial, plays a very crucial role in transportation infrastructure, most especially in intersection. It allows smooth traffic flow and reduces congestion. Unlike other usage of traffic signals, roundabout allow continuous movement. So which leads to maybe important things like lower vehicle emission, contributing to environmental sustainability. So I would say they are good things. They also reduce accidents. Yeah, that's all I have to say. Thank you.
Thank you. So you're telling us we are designing a good infrastructural component, right?
Yeah, that's correct.
Fantastic. Thank you. Thank you very much. And that was a very good explanation of the use and the advantages of roundabouts. All right. So thank you. So I want to go straight into today's presentation, and of course the session that we are going to do today. The session is going to be categorized into three parts. The first part is, number one, to demystify what roundabouts are all about. Because my understanding is there are quite a number of myths about the use of roundabouts. And I will start by first playing a short video here so that we can first understand the myths that we have. Let me go straight into it. About myths. Let me go to rate right there. And I will be able to replay this video. So, and give out some takeouts in the chat box.
You probably see elderly drivers are the ones that are stopping at the roundabout and not knowing when to join.
I don't think they'd be safe at all.
Yeah, I agree.
People just like run right through them. They don't really stop, or I think they're more dangerous.
I don't even know if a semi-truck could make it around that corner.
Modern roundabouts are a newer form of traffic control in Minnesota. They are becoming increasingly popular due to their safety, efficiency, and economic benefits. However, there are many misconceptions and misunderstandings that people hear about roundabouts. In this video, we will demonstrate why roundabouts are a viable alternative for intersection traffic control. Myth number 1. Modern roundabouts are not safe for pedestrians and bicycles.
I think they would have a high likelihood of getting hit or trying to intermingle with traffic would not be good.
Well, the big advantage that roundabouts offer to pedestrians and bicyclists is low vehicle speeds. All the vehicle speeds are 25 miles per hour or less at the roundabouts and at the crossings. And the other big advantage is that all the sight lines at the crosswalks are much better because all the crossings are at 90 degrees. It makes it much easier for drivers and pedestrians to see each other and to react.
I went to a location within Cottage Grove that has a multi-lane roundabout, and there's a signalized intersection next to it. When I was at the signalized intersection with a group of people waiting to cross, I happened to look at some drivers who were near me, and what they were doing is they were looking at that light. They weren't looking at anything else. They were looking at the light for their chance to go. They weren't really paying attention to pedestrians. They were looking for the light to tell them where to go and when they can go. When you were at the roundabout, one nice thing that I noticed is as the drivers were coming up, they were looking at you. As they enter the roundabout, they have this wide view as they come up to it, and they can see pedestrians.
I can tell you from experience that the intersection in which we're taking the signal out and adding a roundabout has been very difficult for me to cross with my children. So I'm looking forward to having a roundabout where I know that the speeds will be reduced and people will be more aware as they're traveling past.
Modern roundabouts provide several options for cyclists. Novice cyclists can utilize the trails and crosswalks and enjoy the same benefits as pedestrians. Experienced cyclists can ride with traffic inside the roundabout, following the same rules as motorists. Myth number 2. Modern roundabouts cause more crashes.
I think at first they probably cause more just because people don't know a lot about them. People are so used to traffic lights and stuff.
A study by the Insurance Institute for Highway Safety examined 24 modern roundabouts that were converted from stoplights to roundabouts and found a 70% reduction in injury-related crashes and an 89% decrease in fatal crashes. This reduction in crashes is due to the three main safety features of roundabouts: low speeds, gentle crossing angles, and separated traffic flows.
At typical intersections, you've got traffic that are crossing each other. And when you've got that type of crossing, you've got a crossing conflict. So that if a person blows the stop sign or they go through the red light and a person other hits it, it's that type of crash that you'll have. It's a T-bone crash. Whereas at a roundabout, people are going in generally the same direction because the circulatory roadway is going this way. The entering traffic has to go that same direction. So if you do hit, it's going to be a glancing blow as opposed to that T-bone crash that you'll have at a typical intersection.
You know, as a state trooper, we go to crashes every single day, and crashes are caused by driver decisions in almost all situations. When you have a traffic safety device like a roundabout, you're taking away some of those errors that drivers can make. So although we still may see crashes at them, we're going to see less crashes involving fatal or serious injuries. And those are the crashes that, as state troopers, we go to, and it's devastating to families to have to go through that, especially when they know it could have been prevented.
Myth number 3, modern roundabouts are built too small for trucks and buses.
I don't even know if a semi-truck could make it around that corner, unless it's like an exit to a highway maybe, but...
The curb around the center of the modern roundabout is actually a truck apron. It is designed specifically to allow buses, large trucks, and trucks with trailers to maneuver through the roundabout by allowing the truck's rear wheels to roll onto the truck apron when necessary. The truck apron is not to be used by regular passenger vehicles. It is not a sidewalk, and pedestrians are not allowed in the center island.
Well, as is the case at any other intersection, drivers should give trucks plenty of room, especially when trucks are turning, because they might need to swing wide or straddle over multiple lanes. So if you are behind a truck as you approach a roundabout, do not enter next to the truck. Give them plenty of space to make their movement.
The modern roundabout myths that were covered in this video are generally related to the perceived operations and safety of roundabouts. After seeing the information in this video, we encourage you to do your own research on roundabouts. MnDOT and other local highway agencies have abundant online resources on the topic covered in this video.
So thank you very much. So the first phase, or the reason as to why I've been able to, the reason I wanted to share that video is for you as the designer to understand what are some of the misconceptions or what are some of the dangers that are associated with roundabouts. So the first point, when it comes to operation and safety of roundabouts, it is very important for you as the designer to, number one, think in 3 perspectives. The first perspective that it is important to think in is, one, as the road user. So how is the person that you're designing this infrastructure for, how are they going to use it? When we are talking of the road users, we are talking about both the motorized and the non-motorized traffic. So the first reason, or the first concern and the myth, is about safety of pedestrians. This is not something that we can disregard immediately, because yes, the pedestrians are at risk, but it does not mean that it's the roundabout that is exposing them to these specific risks. Most of the risks that come or that pedestrians encounter at roundabouts is mostly due to the user. How are the people using these roundabouts? How are they using them at this specific point? So we have seen also a reduction in accidents, fatal accidents, due to low speeds, separated and also separated traffic. So now let us go to now thinking about this from the perspective of a design engineer or a designer. So you need to know, number one, the challenges that you're addressing before even you go to design is, number one, there will be safety concerns. Number two, there will be congestion, of course. Number three, that is where we are talking about channelizing the traffic. And then after that, you'll be talking about the operational phase, and then the users, that is the motorized and the non motorized traffic. So let me go straight into a small, very brief presentation so that now we can understand roundabouts from the perspective of an engineer, the perspective of the person who is designing and also constructing these roundabouts. So with your permission, of course, I will be able to share a very brief presentation that I had prepared specifically for you. So please, I would encourage you to pay close attention before you go to the software, because I understand that the other inconvenience or the other reason as to why we face a lot of challenges in designing infrastructure is because the design engineers are directly jumping into the software without even having a detailed analysis and an understanding of the principles that you need to consider before you do the design. So we always say garbage in, garbage out. So Civil 3D, Viaduct tracking, MicroStation, any other software that you will have is not the savior. Even BIM itself is not the savior. The savior is you as the design engineer taking the right steps and the approach into design. And this is one of the big missions that we have at Ronsab. It's to bring an holistic approach into design, for you to think in 3 dimensions. You're thinking from the perspective of the engineering principles behind design. And then after that, there is the practical application. Then after that, you think about the actual construction. And then after that, you think about operation. And then after that, you can also think about maintenance of the infrastructure that you're talking about. So this is also the dimension of the approach that we take in our design trainings. So I want you to watch this space, follow through the presentation keenly, look at the faces keenly. Don't just focus on the software, think through the process first. And the moment you take the right steps and the right approach to design, you will always have a very balanced or holistic design at the end of the process. So today's session is about design of roundabouts. And the first thing that I want to talk about is, of course, the types of roundabouts that we have. So these type of roundabouts are, number one, they are based on the utility or the application or the site conditions that you will have on site. The first one is, for example, a single lane roundabout. This one is ideal for areas with very moderate traffic. So these are, for example, for roads that do not have a cumulative standard axle of around 0 or 500 to 1 million per annum. The second is the multi-lane roundabouts. These are designed to handle high traffic volumes with multiple circulating lanes. Then after that, we have the turbo roundabouts that are unique spiral lane markings that reduce lane changing or and then collisions at roundabouts. Because one of the biggest causes of accidents and collisions at a roundabout is the driver behavior. You switching lanes when you're already inside or already in the roundabout. The other one is the signalized roundabout, which incorporate traffic signals to manage flow in high traffic areas. But of course, when we are talking about signalized traffic, they have their own advantages and disadvantages. Then we have hybrid roundabouts that combine the elements to meet the specific traffic or geographic needs. So these choices are based on the site conditions, and also if you carry out the traffic survey and study for you to understand which type would you want to apply at that specific point. The second is, of course, the factors that influence the choice of providing a roundabout. So what are some of the things or the reasons as to why you would consider and which ones are suitable for you to recommend? the construction or introduction of a roundabout. So the first one is, of course, safety. Safety is very important. You can see that is one of the concerns also of the public. So roundabouts, we introduce roundabouts at sections with design speeds less than 60 kilometers per hour. But also you can introduce at speeds less than 80 kilometers per hour where you provide overhead lighting. Also, according to traffic flow, if the major flow road is less than 3 times the minor road flow, then it is justified for you to provide a roundabout at that specific point. Then also there is, of course, site conditions where you need to strike a balance between additional land acquisition and increased capacity or traffic capacity. So you need to carry out a cost benefit analysis. So you are proposing to introduce a roundabout, and this is the traffic that we are having here, but we are required to acquire this additional amount of land, mostly in urban areas where land acquisition is very expensive. So you're like, is this really justified? After that, then there is, of course, driver behavior, where we need to reduce accidents and increase the road capacity. So we'll talk about a different concept, that is the modern roundabouts. There are, of course, the traditional roundabouts that were used in the 1900s. And then there is, of course, these 1900, for example, the first roundabout was built in New York City, where it was around 1905 in Columbus Circle. And then these roundabouts were not performing very well as the country, or rather the traffic, was growing. So at this point, around 1950s, there was downfall of roundabout applications, especially in the Americas, but also there was greater adoption when it comes to Europe, Africa, and other parts of the country, or rather of the world. So, for example, at the moment, the modern roundabouts are around, the leading country is France, that has around 15,000 roundabouts within road network. So the next thing is the principles of modern roundabouts. So in the principles, I'll be talking about one of the most important concepts that will also be guiding us in the design that we are going to do later on in this session. And this principle is called the yield at entry, or offside priority. This principle requires that vehicles on the circulatory roadway, that is the vehicles that are already in the roundabout that are moving, all right, they have the right of way. So if the vehicle is already inside the roundabout, if that is the right word to use, then they have the right of way. Then the yield signs are used at the entry to maintain free flow and high capacity. So we'll be talking about the yield line is the dotted line that you see here at the edge here. And this one is meant to control how vehicles are maneuvering, how they are entering and exiting, and mostly it's entering the roundabout. So the roundabout also operates most safely when their geometry forces traffic to enter and circulate at low speeds. That is the key thing. Roundabout's geometry is meant to force traffic to enter and circulate at low speeds. This also justifies the reason as to why, when we are doing design, number one is the major traffic. The design speed of the major traffic should be something around below 60 kilometers per hour, 80 to 60 kilometers per hour. Secondly, when you are selecting the design speed of your roundabout, should be something around 50 kilometers per hour to 30 kilometers per hour. So you want to maintain vehicles to have very low speeds within the roundabout. This reduces accidents and collisions in roundabouts, and then ensuring the safety of the road users. Factors that influence the choice of providing a roundabout, of course, is you need to have adequate circulation space compatible with entry winds. So this means also you need to have sufficient land. Roundabouts requires a considerable amount of land for construction. Also, you need to have a very simple and clear and conspicuous layout. So you don't need to do any complications when it comes to the layout. That's why you see the layout of roundabout is very easy and clear for the drivers to see. And also the sight distances are very adequate. Then, of course, the deflection of traffic to the left or right, depending on which side your country drives on, that one promotes a gyratory movement. So the gyratory movement is that circular movement along or within the roundabout. And in this case, then it ensures low traffic volumes. Of course, the biggest issue here is road users entering the roundabout through the wrong lane, and of course, taking a lot of time within this way. So we'll go also to the next part, which is the definitions that we'll be looking at. We'll be looking at the entry angle, exit angle, entry radius, exit radius, central island, and such. But this one will be better explained practically when we'll be doing the design. Now, here is the most important one: pedestrian crossing considerations at roundabouts. So pedestrian crossing locations should achieve a balance of three important things. The first one is the pedestrian convenience. So, and this is the concept that we say you are not designing for you, you are designing for the road user. You are not designing what is in the manual, you are designing what is applicable on the specific site. So you need to understand how is the road, or rather the users, our pedestrians, behaving at this specific point. Am I positioning the crosswalk? For example, I've seen scenarios where you are providing a crosswalk or a zebra crossing, whatever you call it in your country, 100 meters away from the footbridge. You are providing a crosswalk 200 meters away from the bus station. So what happens is you see the pedestrians, they find it inconvenient for them to move to where you want to direct them. So in the design, you need to consider what is the convenience of pedestrians, the pedestrian safety, of course, and then the roundabout operation. Because also the position where you're positioning your walkway or your crosswalk should be not, or it should not interfere with the operation of the roundabout. The other one is the principal design requirement is number one. The island should be simple geometric shapes. Most recommended is a circle. And if the site does not give coordinations, there are no coordinations for a perfect circle, then the other element should be joined with circular curves. But at this specific point, you want to reduce or avoid the use of straight sections. Entry winds may be widened for multiple vehicle entry. Of course, the entry width is the number one determiner of the capacity of a roundabout. So that one should be considered, and we'll see the figures that you're going to use in our design. Also, you need to prevent excessive vehicle speeds by forcing vehicles to enter and circulate at low speeds. And in this case, that's why we have the speed limit signs. Sometimes also people consider having rambo strips just a few meters from the roundabout so that you can be able to slow down the traffic. Then the other point is the guidelines, and this is another key area that I would want you to talk about. The weaving section is not mostly used in the modern design, in the modern design of, or rather in the modern roundabouts, because this was more of a traditional section, and then it gives allowance for a lot of collisions. So we have the minimum entry radius. It should be between 25 to 30 meters, very important. The minimum exit and central island radius are chosen based on design spins. So these are recommendations that are, of course, given by different standard road design manuals, like, for example, the AASHTO standards, the Uganda road design manual, Kenya road design manual, South Africa, and different countries. They have specifications on this, and we'll be exploring some of them today. Then there is the minimum island radius is chosen, of course, that one I've said. Then there is the minimum lane width should be 3.5 meters. So you don't want to have very narrow. In as much as the argument in the AASHTO standards is that you need to restrict the geometry. For you to control the spins in roundabouts, you need also to limit or constrain the geometry in roundabouts. But in this case, the minimum length, we are talking about 3.5. The entry angles, of course, should be larger than the exit angles because you want more access, you want more visibility. And then after that, you need desirable entry angles of 40 to 60. And then after that, there is something that I normally call a safety audit. And this safety audit is very important. And all proposed layout should be checked against excessive vehicle spins. And this is the biggest challenge when it comes to roundabouts. If you allow motorists to get into the roundabout at higher speeds, you are expecting collision. It's as simple as that. So how do you check to ensure that the geometry that you've provided does not provide or does not allow drivers to drive at a higher speed? So there is this concept where we use this test path analysis. And in this case, you connect two approaches, for example, the entry and the exit, just like you can see at this point. And then these 2 points, and they are tangent to the island here. The radius of this curve or this path that we assume a thickness of 2 meters, the radius should not exceed 100 meters. So in this case, you are very guaranteed that no vehicle, like the driver, the geometry will limit the drivers to have to drive through the roundabouts at an excessive speed. So for example, if you see, look at the scenario that you have in the picture here. If this radius was bigger, that means it's a little bit more straight. At this point, it was more gentle at this straight. It means that an approaching vehicle is going to have more like a straight approach. So a vehicle that is moving from the right-hand side here will be able to have like more like a straight approach to this point. So this driver will not have a reason to slow down. But when this radius is a little bit constrained or anything less than 100, the driver has to reduce the speed so that they can make this specific turn as they move to wherever, or they make the maneuver out of the roundabout. So achieving this is most critical because it reduces the conflict and, of course, the accidents that you expect at that point. So we go to detailed design of roundabouts, and this is where I would like you to note them down. Number one, we need to select the entry ready for different major road design speeds. So this is where I was talking about the entry radius, which is the most important aspect, is chosen based on the design speed of the major road, not the minor road. So if the design speed of the major road, for example, is something like 80, you remember we said that you cannot provide a roundabout for an highway that is having a design speed of 130 kilometers per hour or 120 or such speeds, right? So let's say, for example, we assume a design speed of 50 for the major road. The reason as to why this point, of course, the speed will be very low at this point because you don't want vehicles moving at higher speed. So the entry radius, the minimum that you can have at this point is 20 meters. And then there is the recommended and the maximum. You do not have to use the maximum, or the choice here is dependent on land availability. Remember, roundabouts requires a considerable amount of land for you to construct at this point. So it is important for you to use, for example, the recommended or use the minimum depending on the site condition. For this demonstration, we'll be using 20 as our minimum entry radius. Note that down. That is the entry radius. The second one that I want us to look at is the exit and the central island radii. Remember, the exit radius and the central island radius, they are chosen based on the entry radius. So we choose the entry radius, which is 20. If we do that, the next thing is the exit radius. So for example, in this case, if we chose our entry radius of 20 meters, the exit radius is 40 meters. So note that down as well. So the exit radius for our roundabout will be 40 meters. And then after that, these two geometric requirements must be able to correspond, or rather the central island, the radius of the central island must be able to correspond with the parameters that you've chosen for radius, for entry and exit. And this is the concept. I'll go back to this again. This is the same concept that you're seeing here. So this radius at this specific point, because this is the approach, we are looking at it from the right-hand side. This is the entry radius, and this is the exit radius. So technically, these two elements must be able to communicate with the center or with the radius of the central island at this point. So that is the ideology, or rather the rationale behind the choice of the radius that we have here. So in this case, again, we are going to work with the recommended value of 30. For this case, we are going to use a 30, and then we see the results that we get when we start the modeling. Now, after that, we have what we call lane specifications. Lane specifications. The lane specification, again, is tied back to the central island radius. Because, for example, the gyratory movement that we are expecting to have within the roundabout, those lanes will be basically an offset of the central island. Also, when you're talking about the central island, we'll be talking about a very important aspect, which is called the track apron. So the track apron is basically the surround of the central island, and this is meant to accommodate large tracks. So we all know that there is off-tracking when large trucks try to negotiate curves, and also when they want to end, or they are accessing or they are using roundabouts. So it is important for you to have these in consideration when you're doing your design. So we'll also account for the track apron also in our design. But in this case, if we're having a 2-lane roundabout, in this case, there is the inner lane and the outer lane. So the inner lane should be wider, which is 4 meters, and the outer lane will be 3.5 meters. Please note them down as well. After that, we will be talking about the maximum number of lanes that you expect. For example, for a single lane approach, the maximum number of entry lanes, we have them as 3. And for 2-lane approach, we have the number of entry lanes as 4. Also, you need to note these down. Those are the maximum entry lanes that you need to have, and we'll be using them in our design right today as well. So the other one, those are the main specifications that we need to consider. So we have talked about the entry radius, the exit radius, the island radius, and then the circulating lane widths. And we are talking about the circulating, the lanes that are within the roundabout itself. And then also we are talking about the track apron. So those are the key things that we need to look about these. And you need also to understand that the lane widths, especially for the circulating lane widths, they are the main controlling factor for capacity and performance in modern roundabouts. So if you have a very constrained geometry at that specific point, you are going to affect the capacity of the lane. So also when you have the number of entry lanes that you're having at that specific point, it means that you're going to accommodate a higher traffic. Then after that, we'll be talking about the geometry of the different parts that we have, for example, in our roundabouts. Apologies, this one could not be very visible. So when I'm talking about the circulatory roadway or the circulatory lanes that we are talking about, they are the lanes that are, this circular movement around the central island. This is the circulatory lanes that we are talking about. Then after that, we have the arms. So these are the arms. For example, what we have here, we have one arm here, 2, 3, 4 arms here. Then after that, we have what we call the splitter island. So the splitter island is what is splitting, to use a layman's language, what is splitting the two lanes here. So the traffic that is moving in this direction and also in this direction. So this is also dependent on site conditions, where we can have it as a raised curb, which is the most recommended, so that you can have a raised curb at this specific point. But also you need to have adequate road marking to demarcate the different geometric parts of your roundabout. Then the other important thing that you need to understand is what we call the vehicle yield line. So the vehicle yield line is basically where the vehicle, as just a layman's explanation, is where, for example, if the vehicle is accessing the traffic, this is where you need to stop before you get into the roundabout. And also this is the section where you will be exiting from the route, but it's mostly at the entry. And then after that, you need to think about the crosswalk. And the positioning of the crosswalk is always tied to the vehicle yielding line. I have seen a lot of researches that are recommending 6 meters from the yield line. Some are recommending 25 meters from the yield line. Others are recommending 10 meters from the yield line. And we are also saying that we are not designing for ourselves, we are designing for the road users. So we need to look at people with disability. How are they able to access in this point? Okay. What is the accessibility? What is the condition at that specific point? What is the convenience of the road users at that specific point? So this is basically the key points that we're looking at. And then we have the central island. And the central island is basically to guide also the drivers. And we should not be having a lot of obstructions, because the moment you are approaching a roundabout, you need sufficient sight distance. Your line of sight, the line of sight of the driver, should not be obstructed, especially, for example, if you're, let me now put this in context. If you're driving in Kenya, for example, we normally drive on the left, right? So this means if you get entering a roundabout, you need to watch out for vehicles coming from the right, because that is where vehicles will be approaching, all right? So also, as you're approaching, you need also to be aware, where are you going and which lane are you getting into? And, there's something that is called, I remember when I was doing my driving school classes, I saw something that was called MTRB. I don't remember the meaning. there is motorboard or something like that, you know, that guides you on which lane. If you're going to this, you need to get to lane number 2 so that you exit appropriately in the right lane. And I think that is one of the most ignored classes. It's one of the most difficult, yet one of the most ignored classes. And that also influences the driver behavior. It influences the driver behavior, because roundabouts is not about where you are entering. It's about where are you going, so that you can know how are you going to approach the roundabout in that specific point. So that's basically the little that I had prepared for you. So we have the specifications. Number 1, we have the entry radius. Please note down. We have said that we are using a minimum entry radius of 20 meters. We are talking about the exit radius. In this case, we are using an exit radius of 30. We will also be using a central island of 30 meters. Yes, we are using a central island of 30 meters, but this is also dependent on site conditions and land acquisition. So don't go out there, design your roundabout and say James said we should use 30. It's dependent on site conditions in that specific area. If it's in urban areas, of course, you don't have the luxury for such amount of land to do your roundabout. Then we talked about the lane widths as well, and we said the inner lane should be 4 meters, the outer lane is about 3.5. I'm just doing a recap so that when we go to the actual modeling of our roundabout, it becomes easy for both of us to follow through and be able to apply these specifications. Then we said that the track apron specifications, I have seen that by practice, most of the designers recommend the use of around 0.5 to 1 ISO 3 feet to 15 feet for those who are using the imperial standards. And also you can be talking about 1 meter, 1 meter to 1.5 meters. So that is also dependent on that. So I will also take a small break so that we can be able to watch one interesting video. I don't know whether you can see my screen. I want to show you one interesting video here. I don't know what are you seeing? I don't know whether you can see it. Let me just stop sharing and then share again. And I want us to understand how large vehicles use roundabouts. Because when it comes to design, you are designing, you need to have the vehicle in mind. What is the design vehicle that you're going to consider? Because if you don't have a design vehicle, then it means that whatever you're designing may not necessarily serve all the road users. So for this case, we will be considering the maximum large trucks, large articulated vehicle with 5 axles, standard axles. That is what we'll be considering as our design vehicle. So put in mind the design vehicle characteristics. So I'm sharing with you right now a video to show you, number 1, the track apron, because that is one area that people don't, or that slips off our minds. And then after that, the behavior of road users at that specific point. So stay on and watch this. So this is basically the track apron that I was talking about, which is around the center of the roundabout that has a low raised area that is called the track apron. So it is the red section that you're seeing here. This is what we are talking about. And you can see for the smaller vehicles, for the small vehicles, passenger vehicles, they normally don't get to use these specific area. So this is set aside to take care of the off-tracking of back wheel of the large articulated vehicles. And as you've seen, when you are designing roundabouts, we must have a large vehicle as our design vehicle. Right. So now that we are done with that, with all the theory, right? We have done with all the theory. How can we now proceed and get to apply these principles in our design? Let me just look in the chat box so that probably if there is a question, I can be able to so this is a question, an interesting one. When we talk of the central aisle radius, does that include the track apron or the raised section only? So that one is including the track apron, and I will show you how you are accommodating these in our design. So let me see whether there is another question of interest. There is none. So let's go now into modeling the intersection. So I go straight into it. Allow me to share my screen. For my people who are on LinkedIn, I hope you are not having a lot of challenges. And if you normally have a small lag, so stay tight, and don't ghost us, all right? So stay there with us. I got you. So let's go to Autodesk Civil 3D. This is one of the superior softwares that you use for road design. I actually carry out a little bit of, not a little bit, I carry out traffic design, or rather geometric design trainings. And our course is more than just Civil 3D. If it is about Civil 3D, we could not be doing it. We are doing this from a technical perspective, just like a design engineer. So we are not doing trainings just to know the software. We are carrying out trainings for you to have a very good understanding of the software, all right? Not only the software, but also technical specifications, application of road design manuals, interacting, working on projects, and so that you can upskill and also build practical, I normally call them rare and valuable skills. So I don't think whether using Civil 3D is a rare and valuable skill. I don't think using Revit is a rare and valuable skill. You need to have a technical grasp of these design tools. And over and above having a technical grasp, you should be able to integrate design principles, make decisions as a design engineer. And even after making decisions, you must be able to communicate your decisions, which is one of the biggest challenges that I've encountered with most of my trainees. So you only know you are saying my radius is 10, my radius is 300, my radius, but you need to understand why did you choose that. So also for my people who are also in the approval section, so they now have an understanding of why am I approving this design, so that even if something happens and you are asked, or, they come at you, why did you approve this? You have an understanding. So you may consider joining one of our programs. And of course, we have an intake that is happening on the next cohort is going to start on 9th of July 2024. That is next week on Tuesday, God willing. And if you're interested and you would want to gain rare and valuable skills above just clicking points in the software, designing projects that you can do project presentations, you can explain your engineering decisions, that you can provide accurate setting out data, the construction data actually, that if you are on site and you're doing construction and your employer, whether you're working for a contractor and a consultant, if they ask you, why did you make these decisions? You have the confidence to explain what exactly are you doing and why did you make those decisions, which is a little bit challenging, but we have the captains, we have deep cubes, you're learning from people all around, from around the world. So, yep, this is the session for you if you really want to be good at your craft. Everyone can go and do a basic Civil 3D training, can go and do basic Revit training, can go and watch videos and tutorials on YouTube, but not everyone knows the technical specifications and application of design principles into their drawings. So this session, we will be talking about intersection design, which is also another course that I will be launching very soon. And of course, it will be available on our website, which is Roundabout. All right. Okay. I don't know where it is. I don't know. I cannot be able to type, but anyway, it's roadsup.org.com, www.roadsup.org.com. We'll also be having self-paced courses there. So feel free to interact with the website and get to learn. So this design is basically number one. We're having some loop roads here at grade intersections for this point, but this is another topic for another day, another webinar that we'll be looking at it so that we can be able to do this. So we are taking a tour. So these are loop roads. For example, this is the access. You are moving from this point, from the left-hand side, and once you drive through this area all the way, you take this loop, and then from this loop, that's when you can move to this other point. If you missed it and you want to go back to where you want to be, you came from, you will use this slip road at this specific point, this loop again. And then there is another feeder road here. That's another loop. And then another one that is exiting at this point. After that, now, when you move to this point, if you want to proceed, you go all the way to our point of interest, which is right here. So at this point, we are encountering a section where we are having 4 roads meeting at this specific point. And you cannot do an at-grade intersection at this area because it's more of a low-lying area. It's more of a, I call it a flat terrain. So you can see it will be very expensive for you to think of a grade separated intersection at this specific area, right? So the most suitable recommendation that I could recommend in this area is to have an intersection, or rather an intersection that is in terms of a roundabout. And when we talk of a roundabout, we want to do a modern roundabout with the specifications that we have gone through in the previous 30 minutes, in the past 30 minutes, okay? Now, if you look at the lines, the polylines in yellow, this is the initial design that was, or the existing condition of the road. So there was just a basic T-junction in this area, but we want to open up this section so that also traffic coming from the left-hand side can be able to access the road here conveniently without having accidents and congestion at this area. Now, the other point, and the reason as to why you also need to understand land subdivision, is your design could probably be able to affect the adjoining or adjacent land parcels. So you need also to know how to do land subdivision as a design engineer also, because This is not only for surveyors. So this one is a mosaic that I also mounted on this design, just to have a perspective, so that as you are recommending the geometry of your roundabout, you are mindful of affecting the adjoining parcels of land. That's why we said, in as much as we are talking about roundabouts, they require significant parcels of land. So you need to know parcel land subdivision as an engineer. So let's get into it. The first thing is we're having two roads that are intersecting at this specific area. So for the interest of time, I cannot go all the way to doing alignment. So that is basically also something very simplistic. And that is the assumption. So the assumption number one for this webinar is you have the basic knowledge. You can be able to create an alignment. All right. You can be able to do land subdivision and parceling, but it's not very important for this case. You can be able to, you understand the interface. You can be able to do polylines, you can be able to design your profiles. You can be able to do a little bit of, pavements, design. You can be able to come up with an assembly for that matter. So those are the assumptions. And also you are able to create surfaces, because for us to model our intersection, it must be able to target the existing ground in this area. So let's get into it. And today I want to do it a little bit different. I'm not going to use Civil 3D per se. I want to introduce a new one, which is the vehicle tracking, which actually is another product by Autodesk. And it's very, very, very good in designing roundabouts. And you can be able actually to visualize your vehicles using, or you can be able to animate your vehicles using the intersection. God willing, we'll be able to do it as well. So we go to vehicle tracking. If you vehicle tracking, but also you can go to the home ribbon that is in Civil 3D. Once you go to home ribbon, you go to create design panel. In the create design panel, you will find intersections. In intersections, you have create intersection, create roundabout, and apron, and do configure roundabout tools. So you can be able to use create roundabout function. And once you go to create a roundabout function, you will be taken to the library of all the tools and the roundabout standards and specifications that you have, or that you can consider for you, or when you're designing a roundabout. Okay. So this is the first one. For example, we have what we call the country kits, and different country kits have their roundabout design standards. And for example, we can see Australia, Austria, Brazil, Britain, Czech Republic, Danish, that is Denmark, if I'm not wrong. This is Netherlands for Deutschland, I don't know. Italian, Norwegian, Polish, Romanian, Spanish, Swedish, and all of these. So, and then there is also the pool right here. But now you find that for most of the African countries, we don't have a specific country kit in this matter, but we'll be using the US Federal Highway Administration, or the AASHTO recommendations that we have for roundabouts, which you just need to understand how to tweak them, and you can customize them and use them in your country. But also, if your country have a specific country kit, you can be able to use it as well. So you can adopt from your respective countries here. So after that, you go to the US Federal Highways Administration, and then we go to, let me collapse these. You can go to roundabouts. And in the roundabouts, we need to use the 2010 version for undouble lane. So we have a mini roundabout, rural double lane roundabout, rural double lane spiral marking, all of these types. But for this case, we are using urban double lane roundabout because this road is in an urban setting. So once you select, you can
Sorry,
hit
we
on
can't see your screen.
I think your screen is lighting.
You cannot see my screen? Sorry.
Your list, yes.
Country list you are mentioning, it's not seen in the screen that you are sharing. We can just see the Autodesk interface.
Oh, sorry about that. Let me stop sharing and share again. Sorry. Thank you for letting me know. That's super. All right. Thank you. So let me reshare again. If I share a specific window, okay. Let me share my entire screen then.
You are muted now.
Okay, if I share my entire screen, I'm getting muted. So, all right, let me see, what can I do? Can you see it, please? Let me know.
We see the Autodesk interface, but not the country kit list.
Okay, sorry. Okay. All right. I know the biggest challenge we're having is because we are live on LinkedIn as well. So if I share, okay. Aha, all right.
You are muted.
That is now becoming a challenge. I don't know. Wesley, are you here? You're always saving me, gentlemen. Come and save me. Okay. I don't know what to do now. Okay, entire screen. Am I muted now? Please let me know.
You're good.
All right. Then again, I'm sharing my screen. Let me open a new tab. Let me just open this tab again. Sorry for that. Can you see now the country kit?
Yep. Good to go.
You can see it now, right?
Right, yes.
Super, fantastic. Thank you. So, all right, thank you. So I'll just repeat it. This is the library where we have a collection of all the design standards for the various roundabouts that we have. So I'm just focusing on the roundabout. And in this case, in the library, and we have Australian and all these countries. But for this case, because also the software is more of an American product, and that is also the specifications that you guys have been using also in the design of the geometric in drones and all of that. So for this case, we'll be using the US junction design standards. But also, if your country is among the list here, feel free to use it. So I will go to the US junction design standards and then expand that. And then after that, there is the US Federal Highways Administration. There are all of these types that were developed in 2010. And of interest for us because of the context is we are using it for urban double lane roundabout. That is the type that we'll be using. This type has the visibility sightlines, it has signages, and also it has road markings. So that's it. So if you wanted to proceed with the design, you just click on proceed, and you will be asked, you know, to do all of these other methods. So let me stop from this point. Let me just cancel so that now I can be able to use the vehicle tracking. So vehicle tracking is more of a plugin that you use with Civil 3D for geometric design, and it's very good also for visualization and the swept path analysis. So that is also what is used for. For me, if you launch it, you go to the home ribbon. In the home ribbon, you'll be able to see there are ribbons here: home, insert, annotate. There will be the other one that is, it will be ended after featured apps. You will have the vehicle tracking. So in the vehicle tracking, I will have the honor to take you through the basic setup or just the interface. And the first thing is the settings. So in the settings, this is where you have your system settings. You specify your system settings, for example, the units. So we have the settings wizard. You can be able to set the units here. One drawing unit represent what? Also the scale. You go to next, you have the vehicle editing units. So the moment you've set the metric or the imperial system, the vehicle units will be directly in meters. That is the distance. Also, the preferred units will be for speed, kilometers per hour, and the preferred angular units will be in degrees. Then you can go also to layers. So you can use a layer naming convention that is adopted in Civil 3D, or you can also prompt to create a new layer every time that you insert a new object from the vehicle tracking. The next one is the turn transitions. So in this one, let us limit them forward turn rate. Let us use as they are. The other one is the forward speed. If you would want to specify the speeds, you can see this one you need to modify to kilometers per hour. That is fairly good. The only modification that I need to make. And then after that, there is, I don't want to limit the steering. Can you be able to see this, please?
Yes, yes.
Okay, thank you. So there is the steering limits if you'd want to specify as well, and then the dynamics and all of this. You don't need to modify a lot, just hit finish for this one. Then after that, there is the swept path analysis. This is now after you've done your design. You would like to see how will vehicles, you want to simulate how vehicles will actually drive through your section. So we'll be able to do that at a future time. But most interestingly, or most important section is the roundabout section. So this is where we are able to model the roundabout easily and all elements that we need to use. And then after that, we can be able to animate and also use the design checks to verify whether we are compliant with the set standards. So I'll go just to roundabout in this case. So I just go to and roundabout. And you can see in ending roundabout, it is taking us back to where we were, all right? It's taking us back to where we were again, the US junction, and then I will select the urban double-in and then proceed. Once I go to proceed, the Civil 3D will ask you to set this as a default. So I don't want to set it as a default because I'll be using different versions. And then it will ask me for a scale. So I want it 1 meter to 1 unit to represent 1 meter directly. And then after that, there is now the roundabout details. I want you to pay close attention to this place, please, because this is where now we'll be modeling our roundabout. And I want to start first with the name. So I will call this Ron's Hub roundabout. Okay. The description, you can put a description if you need to, and the notes. And then you can say that it will be able to calculate levels. Of course, we want it to be based on the existing ground. And you can see the standards that have been used is what we selected, urban double-in roundabout. And then there is the parameters here. And these parameters are for the island. and I want to go straight to the central eyelet diameter. So we said the central eyelet diameter should be, it should be 30, was it 30 or 40? Something like that. It was around 30, but either way we can be able to modify. Was it 30 or 60? I don't remember. Let me just use 40. And then after that, there is the apron width. There was someone who was asking me whether the apron is inclusive. So you can see you have to specify the apron width separately. So in this case, we want an apron width of 1 meter. And you can see the inscribed circle diameter has been, sorry? Please let us stay mute. The apron width has been, or rather the inscribed circle is the sum of the central eyelet diameter and then the apron width, and then the circulatory lanes, the circle now inside the roundabout, we want to have 2 lanes. And then there is the drawing style. You can be able to modify the drawing style, but let us just assume the default. And then there is something that is called the surfaces that you want to target. So in this case, you can target the existing ground and the final surface in this case. But for me, I don't have a final surface here because I was still modeling. So let us use the existing ground. And then after that, we just hit OK. Once we hit OK, you can see the circle has been created. And all you need to do is turn on the snap cursor and snap it at the intersection. You see, the intersection of the two, and you hit it right there, and then the roundabout will already be created at that point. So you can see the gyratory movements. These are the inner lanes. So we have 1, 2, and then also we have the island at this specific, or rather the apron, and then we have the island inside it right there. Okay, and you can see there are also where it's telling us the inscribed circle diameter is too large. So there are these ones, but we can see how we'll be able to modify that. After now, we have I basically call it the art of the roundabout. We are left now with the responsibility to add the arms, So we start with the major road. Let us start with the major road. And the software is asking you to select the line defining the new access road, center line. So we start with the major one, and this is, for example, the center line. This is the alignment that I previously created. So I will hit on the center line. And now you will have a window to populate the specifications of your arms. So this one, I will call it whatever name I would want to call it. So let me call it roads. This one, I will call this east. Yes, east. And then after that, we will, of course, you can see it's taking levels from the existing ground. But if you wanted it not to pick, you would have specified earlier on. The alignment offset, I want to have an alignment of a offset of a width of the lane, 3.5. The central gap, this is basically the small distance that you see after how can I explain this now? And I can't go back to that point. But it is the gap that you see around the splitter islands. So after the splitter islands, there is that small gap. So let us just have a 0.5 splitter gap at that point. The approaching lanes, you need to know how many approaching lanes do we have for this arm. So in this case, we're having 2 approaching lanes for this section. And then you specify the lane width to be 3.5, that is approaching. And then also the departing, the lane width is 3.5. Once we do that, we hit OK. But should you be stuck and you would want help, so hit on help here, and you can be able to learn what each of these specifications mean. So we press OK. And once we do that, we can see already the arm has been added. You can see it. The arm has been added. I have my 2 lanes here, my other 2 lanes on this other point. Okay. So this is their approaching. So depending on your country, you have the approaching and the departing. After that, I want to add the other major road on this other side. And this one, I will call it, if that was east, I'll call it Roundabout West. And then after that, I will have an offset of 3.5 for the main. A gap of, we said we're having a gap of 0.5 for that matter. We're having 2 lanes at a width of 3.5 and this one at 3.5, okay? And then I get to hit it right there. And you can see that already has been imputed in it, okay? Then after that, we add the other remaining leg or arm. Yes, some call it arm, others call it leg. So no worries. So this one is a Roundabout North City. So let's call it North. This one, we want to have an offset, of course, let's say 3 meters. Let's just vary. And then this is the lane width, of course. We are retaining the lane width. And then we're having 2 lanes as well. But you can change this one also to 1, depending on what we have, because I feel this side is only 1 lane that we're having. So I hit OK. Yes, this is supposed to be 1 lane because it's the minor road, so it's not 2 lanes. And boom, we have it right there, okay? So let us also do the minor road on the other side. Hit it right there. Okay. Okay. I don't know, I forgot to say that we should not model the corridor at this point. But let's work. So if you look at the bottom of my the bottom right corner of my software, that is where now the modeling of the roundabout is happening, just the same way you see in when you're modeling corridors. So this is where you have, but also if you're roundabout and only 3 arms. So that is basically how you could have done it. So I think I pressed the wrong icon someplace, but this is how you could have done it if you're only having 3 arms in your roundabout. And also it has been able to model the corridor automatically for this case. But I want us to do a little bit of heavy lifting now. So this is the roundabout. It has been created. And I wanted to add, for example, let me just go to edit roundabout. So the roundabout is the one in red. And for example, I want to add an approach, and it will ask me to select the line. So we want to add the approach for the other section. So I'm selecting this one, and then I will call it number 4. And then I call it roads. This was south, right? And then this is supposed to be 1 lane, 3.5, 1 lane, 3.5, and then hit OK, and then boom, we have it there connected with what we have. So that is how we've been able to model an entire one. So you can see you don't necessarily have to have a 4-leg or a 4-arm roundabout. You can be able to work with even 3 arms at this point. So we will also be looking about what we call a staggered roundabout that is having 2 staggered lanes, because in this case, we are assuming that this one is proportional. So we have sections where you have staggered. For example, you could be having this other leg coming probably at southeastern distance, the other one northwesterly distance, something around such, okay? So the corridor is modeling. So let's see how intelligent Civil 3D can be able to model the roundabout for us without doing anything. So in this case, the software is able to do corridor modeling. It's able to impute the assemblies. It's able to impute the profiles and the slopes. It's able to do site grading for curb returns, you know, it's able to basically do everything that you can be able to do. So once it does it for you, you can be able now to tweak it according to your preference. So this is the roundabout that we wanted to modify in this area. So let us just, for example, get to visualize it and see. So we select it. Once we select it, we can go to Object Viewer. And once we go to Object Viewer, so this is the roundabout as it is. This is the roundabout as it is. Let me change, for example, let me go to the shades of gray. I don't know whether it's gonna accept. It's loading. You see, so this is our roundabout, just exactly as it is. And you can see it has been able, the software has been able to automatically do the ditches. You can see the ditches here, the grading on the edges, very well done here. And you can actually see even the cross sections. Let me rotate these. So you can see the lane, you can see the curb returns. So, sorry, the capstone, you see the curb and gutter, you can be able to see them towards the edge. This is the lane, this is the inner lane, this is the outside lane that we have right there. So let me be able to pan it, right? So we are just visualizing, so you can see the ditch. This is the daylight right here around the this section. You can see one point where there was inadequate triangulation at this area. We are able to see the lanes, you know. You can see it's actually even having assembly insertions at very close intervals. This is the curb and the gutter. You see, this is the capstone. You can see the edge of the capstone here, right there, and then the ditch. So that's basically how much the software can do. But then again, the power remains with the design engineer. Like for example, the software is telling us the inscribed circle diameter is too large. By how much? By 3 meters. This is the symbol, the warning symbol that we have here. Better yet, the software is able also to give us our yielding point. When I was explaining the yielding point, you know, the yielding point is right here, this white line. Let me just, for example, turn off the corridor. I can select, let me just go to this point. So in a roundabout, if you want to edit the roundabout, you go to roundabouts. There is an icon with a pen that is in the first column, the bottommost icon. There is edit roundabout. Once you click on edit roundabout, it will ask you the roundabout and you select the white lines. And this is now the tab where we do the modifications or the editing of our roundabout. And the beauty of it is we do these modifications in real time with a visualization on the left hand side right here. So let's get into rate so that we can be able to modify a few things here and there. For example, I want to go to corridors directly and I don't want to create a corridor. Let me rebuild so that we are left with the roundabout only, the geometry of the roundabout without the corridor at this specific point. That is going to give us a better visual perspective of what we are doing. So, oh, sorry, I closed it, but there is no problem. I can always bring it back. So now it's not very crowded. We can be able to visualize. So this is the roundabout. Let me select the roundabout one more time. I'll just go to edit roundabout and then I select it right here. Let me select it. I'm missing it, but anyway, sorry. So let me zoom this to make it better so that we can be able to see. Gentlemen, please confirm you can be able to see my screen. I don't want anyone to be left behind. So let's go to general. Thank you. So when we go to the general tab, we are able to see the general specifications that we selected. So for example, if you are unable, if you named it wrongly, if you selected the wrong surface, you can be able to do this. But if you look at the final surface, AutoCAD or Civil 3D has been able to create a finished grade surface for you. So that's a plus probably, but you can be able to modify it. Then after that, we go to the round section. This is the type. Of course, it's a normal roundabout. And then after that, we can be able to modify the specifications for each arm. So for example, this is the west. And the moment you select the west arm, right, you can see there is a preview on the left. So even if you don't know the meaning of approach, entry, exit, splitter, and these other things, yeah, you can be able to select the approach. So these are the approach details for the lane. And I think this is good. And we can see the design speed for a roundabout for that lane is 30 kilometers per hour. And what the software does actually, it puts a speed limit sign at that specific point for you so that every motorist, or when you're designing, you don't have to think, which sign do I need to do, or all of these things. You already have it detailed for you right here. Then there's the central gap, and this is the central gap if you look at the preview. So this central gap is aligned with the splitter island that we have here. So if you want it, fine. If you don't want it, you can also be able to modify it to 0. And remember, this is also the section that we do road marking with a chevron, just to warn the motorist. Then there is the deviation offset. You can see this deviation right here. And then there is no deflection for this case. And then after that, we have the arc. For example, these ones are basic. Approach details, this is what we imputed, so that is right. Let's go to the entry. Okay, the preview has shifted. So these are the entry, the design speed is at 32. So if you wanted to modify and bring it back to 30, that is also allowed. The lane width at that specific area, you see when you select on it, it's showing you the lane width. This is 3.5, fairly good. If you want to make it probably 4, you can be able to do that at this specific point. Remember, you want to have a wider one. Then there is what we call the flare lane length, unnecessary 0. All of these parameters, all of these parameters, you can be able to modify one by one. If you want a curb offset, curb taper length, taper ratio, all of these parameters, you have them right there. So also in the exit, so this is also the exit again. You can see the design speed is 30. The width is 0.5. The nominal road width, that means we have 2 lanes at 3.5 at this specific point. And these are the parameters as well. So this is how you get to modify the different sections. Also, if you want to modify the slope, for example, the entry side slope, if in this case, you see, this is the side slope. If you wanted it to be 2.5 or negative 2.5, depending on your specifications, then you can be able to modify all of them at this specific point. So this is how you modify your section. And you can see also you have a section for pedestrian, rambo strips. If you want to include rambo strips, speed stripping, if you want to include the turn arrows, for example, if there is a turn that has to be made here, you can be able to do that as well. So this is basically what you include entirely. So due to the interest of time, we may not be able to detail all of these, but I am promising that we will have another webinar. And also we can have an entire course on intersection design, roundabout, very detailed. You sit down, you go through the learning. So for now, the courses that are on offer is the road geometric design. You can be able to come with us and we're gonna teach you how to do these and do it in a great way. Also, we have signages right there. We have the corridor. So let's rebuild the corridor at this point, rebuild, so that I can show you how now we want to add the crosswalk, how we want to, what is the other part? There was something that was, the central highlight was too big. So let us reduce this to 30. because I remember, yes, to 30. I remember they said this is too big. Apron diameter will be 32 because of that, yes. This is good. Hey, the lane width, lane 1, you see, the specifications for the circulatory section. So the lane width here we said should be 4. And then the lane 2 was supposed to be 3.5, if I'm not wrong. Yes, those two, that is good. And then after that, we can apply. And when you go to do this at your own team, just give some out of unreasonable values here, and the software will tell you that whatever you're creating is a path that cannot be driven on or upon, or whatever that means. And then it's going to convert, right? It's going to give you suggestions and remove the target points where you might have missed the point. Okay, so that is how intelligent the software is. So please be able to, yeah, give yourself the grace to be able to learn these things. It's very good. It's very, 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 very good. Let it build the corridor at this specific point. So I will be having a training that is happening from next week. So if you want to be good at road design, this is the program for you. I will be here to guide you. So we can see Ham4 roads up south. We have everything, and we have even a detail of every specific amp that, or rather the arm, the details that we have. And then look here. So these are the warnings that we have. And this is why you need to know how to modify, just like we have done there. So it's telling you the road width is too small, and it's small by negative 0.61. So you need to increase it by 6.1. This one is 0.3. You need to modify it, and 0.3, 0. You see, all of these rend alerts, they mean that you need to go back to modifying the intersection, or rather the roundabout, so that you can meet these specifications. Okay, so we'll take a time to refine it. This takes time to refine it. You can see also the entry radius that we put as that. It's saying the fasten line entry radius is too large. So this one, it's considering more of value engineering. The radius is at 32, and it feels that that is too much. You are acquiring, you are using a lot of land for no reason. So you will go to this is 1 Ronsab East, and modify the entry radius at this specific point. So that is it for me, my good people. For the interest of time, that is the much that we could cover. Apologies if I've taken a little bit too much of your time, but that's all we have. But just before you go, you can see also the signages have been inserted. So this is the yield line that we have. You can see the sign for roundabout hand is right here. That's it. And it has been inserted in all of them. So there's the yield. There is also the roundabout sign at this point. There is also the yield, and there is also giveaway. Remember, in the theory that we were doing, we said that we use the giveaway signs so that we can control the operation and safety. And anyone who is inside, who is already in the roundabout, is the person who has the right of way. So if you're the person or the motorist who is approaching, then you need to give priority to the person who is already in the roundabout. Another key thing that I wanted to do is, how do we now insert a crosswalk for our pedestrian? So it's super easy. Go to the roundabouts panel, and in the roundabouts panel, you can see, let me hover it. You can see in the third row, you can be able to add a pedestrian crossing, and you can also be able to add a slip lane or a bypass road, and you can be able to remove them. So let us add And also you can be able to add a pedestrian crossing here. You can have rambo strips and sprint stripping. So pedestrian crossing, we select it. It will ask you to select the roundabout. Of course, this is our roundabout. And it will automatically give you a place to give it. So look here, I want you to pay close attention. If I wanted to insert my roundabout very close to the yield line, the software is telling me crosswalk offset from entry intersection too small. So I just move slightly, letters it. This is how intelligent the software is. And you can see anything below 22 meters actually, anything below 22 meters, it's saying it's too close. So that is, you can see when I was telling you that you can work within 20 to 25 meters at least away from the yield point. So the 25 meters, just in case the users are crossing or we have a lot of pedestrian crossing, we have somewhat like a storage lane without obstructing traffic in the roundabout itself. I don't know whether that is making sense to you. So if you say you want your crosswalk just 10 meters, 5 meters, you see that if you have just 2 vehicles, the last vehicle, if people are crossing, it will be already inside the roundabout. That is an accident or a collision at that specific point. So we add for that arm, and then we stretch the other one to another like 25 meters. Let us see. 25 to 30 meters is a fair range. And also depending, we said also the convenience of our people is very important. So you also see, where are these people used to crossing? Where do we have access to a bus bay? Where do we have access to whatever, right? So that you don't just design for you, you are designing for the road user. So that's how you add this one. And the beauty of it, look here, when you add a crosswalk, it also comes with its own sign at that specific area. So when you're also issuing these instructions for construction to your contractor, you already know what you want and where it should be. So let me just put this one right there. It models the entire corridor. So the trick is, if your computer is not very powerful, you may opt not to model the corridor first. So you just do the roundabout, and you've seen how I have been able to untick or remove the corridor. And then after that, you can add all the elements, the ramps, the slip roads and everything. And once you get to do that, then you can be able to model the corridor as the last option. So let me do this right there. And we have the last walkway or crosswalk right there, my people. So there is the much and the little that we could be able to cover today. I'll be unveiling an entire course on intersection design. We'll be doing actually one monthly webinar for us to, to equip and teach each other. So this is not about James. This is not about anyone else. This is about all of us. We are creating a community where we get to learn and grow together. We get to learn and grow together. So my people, I am having a course, so I'm allowing you to look. Oh, okay. Let me stop sharing my screen. I don't want you to get into my business. So we are having, people are texting a lot. Let me see whether I can be able to see this. Yes, I will be able to share this roundabout with you all, people. So I will share it in my because now I don't have all your contacts and emails, and that could of course take ages. So I would like you to join this group where I teach and give tutorials for you to learn. So you can join this Telegram group, and I will upload this design right there so that you can be so that you can be able to see it. And I will also be able to respond to most of your questions tomorrow. So please get to join. That is the link that I've shared with you. That is the link that I've shared with you. So please join this. Yes, the recording will also be shared. I will share the recording on LinkedIn. I will also be able to share the recording in the Telegram group. And the beauty of the Telegram group is I have a lot of other recordings that I share, and you can be able to access them at your own time and at your own convenience. You know, that is the beauty of it. And also I have a lot. So if you join the Telegram group, you will see other lessons that I've been able to create specifically for you. And the lessons are for free, those ones in this one. The channel, it's a private channel, my brother. So that's why I am sharing the link with you. The link is there, Engineer G KTJ. That is it. That is it. So I don't know if someone has a want or something they would want to share. Please feel free. This is your time. My time is done. I have been able to do the little that I wanted to do to you today, people, and I hope you've been able to learn. It is always a pleasure to meet with you people and share knowledge. And, you know, yeah, we grow together. Even if I was the only engineer in the world, what good would I make? That is why knowledge sharing is a very, very important aspect. So follow us on LinkedIn. You can follow my page, James Murithi. Yes, I will share the roundabout. I will share the roundabout. I will share. Can we have seminars anytime for geometric design? Yes. 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 We'll be having monthly webinars on geometric design, where I will be showing you a little tricks and hacks here and there, my good people. So there is no problem. So thank you. Thank you. Thank you very much. Thank you very much for honoring this invitation. Yes, we'll do interchanges. There's no problem. 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 Thank you. Thank you, Saif. Thank you. Thank you. Thank you. Thank you. Thank you. It's also good to see you all here. So now, my good people, if you want to learn highway geometric design, if you want to learn highway geometric design, I am doing it for you. I am doing it for all of you. The same style that you are doing here, but of course this was a little fast because we wanted to, you know, we wanted to cover as much as possible. I did not want to leave it halfway. But if you would want to learn highway design, where you even submit your work and we get to review it, like I'm taking you through step by step, like you're in, I don't know whether in college. This is how I do it for you, my beautiful people. And this is how, and I want to just to talk about it just a minute. So the project is this way. We use Civil 3D for road design. That is the concept. So this course is not about Civil 3D. Civil 3D is just but a tool that you use to create magic. And you need to have an understanding of the technical specifications of road design. You need to understand why did the engineer make this decision? You will be the engineer next week, next year. How will you be making these decisions? So that is what I'm teaching you. I'm teaching you a complete course for a 6-kilometer project road. 6-kilometer project road. You do every single step, starting from points. How do we collect? How do we carry out survey? You know, how are we carrying out survey? How are we collecting points? What are the secondary ways of collecting this Civil 3D? Actually, we are introducing the new phase of using Google Earth, using different sources, Google Mapper, Global Mapper, to extract secondary sources of survey data. That is one thing that is new in the new cohort. So if you want me to take you through that, if you would want to go through this journey with me and hundreds of other civil engineers that are doing this together, that we have done this for 500 other engineers. This is your time, and this is the link that I'm sharing with you here. Just feel it. Once you feel it, I will reach out to you, and my team will also reach out to you. My team will understand. You will tell them, this is what I want to learn. And one thing I'm promising you is, if you are not fit for the course, if we feel you deserve a more advanced course, we'll let you know that this course will be a waste of your time. You would rather do a more advanced course. That is the key thing. We are honest and we are doing this with you. The second point, if you don't have a lot of expertise and knowledge in road design, and you would want to create a niche for yourself, you would want to create a good social media presence, an online presence, a LinkedIn brand. And this is what I tell people, and this is what I tell engineers. Engineering is the most underutilized field that has not gone digital, that we don't have a lot of people sharing knowledge out there. I see personal development, career coaches all over, very few in engineering. We need to come together and share knowledge. And that is the community that we are creating at Roundabout. We are creating a community. I call it a community-based learning, where we learn from all of us. Thank you, thank you, thank you, thank you, George. Thank you, George. Thank you, Jonathan. Thank you, thank you. So come to our community, register here today, and tomorrow I will be looking for you. I will need to understand what are the key things would you want? What are the things would you want to learn? And just before I go, I really want to there is one lady that I really was part of our program, and she did a fantastic job. She is called Vanessa. Let me look for her. Let me look for this. And we have a YouTube video, it's called Ron's Hub. Let me see whether I can be able to see Vanessa, whether she is here. I don't know whether she is here, and she shared her expertise. These are the videos that are available there. So for example, this is what she had to say.
When I was in the boot camp, we were challenged to post on LinkedIn, and we were shown how to, like, a template or an example, especially now when I went to see Gatimu's page. At least I got a few pointers here and there. And then, of course, with my former crewmates, I saw how they were posting. So I posted as well. And I think the bootcamp actually gave me confidence to post. Because if I didn't, if it wasn't pointed out that we needed to post, I don't think I would have posted about it. I would have just been like, yeah, Civil 3D, everybody knows. So at least I'm now among the majority. But now when I posted the first post about Civil 3D, and it was about topo maps, my post really blew up. I didn't even expect that. I think it got a couple of impressions and a couple of thousands of impressions, and I was really amazed. And then after that, I got a lot of following, a lot of people messaging me, asking me about Civil 3D, asking me about the classes, asking me to teach them, asking me to send them videos. Also, even until now, there's a lot of traction in my page. And I think for the longest time since I finished uni, I have never had such attraction in my LinkedIn profile, and I think it's very important, especially if you're done with school, to have such traction so that you can be seen and you can be different from the rest of the graduates, many graduates that are around, because of the issue of unemployment as well. So it's just putting yourself out there and standing out of the crowd. So that's what basically happened. And from there, even I'm getting recommendations or work on this when it comes to topo maps, do this and that. But mostly I've been getting even people who want to work with me. They're asking me for my WhatsApp number, all that stuff. And from different countries, mind you, it's not from Kenya only. Yeah, so that's how my story is. But honestly, it started from no confidence, no skill. Yani, it just started from nowhere, basically. And I'm really glad so far how it has come up, and it's thanks to this group. Yeah, that's all.
Thank you. Thank you. So that's basically it, my good people. So we are not only training on on Civil 3D. Civil 3D is the face, but we're here. If you are competent or you are confident and you want to make something for yourself, this is the place for you. And I'm here to guide you. You are my full-time job to guide you through these, to do research for you, yeah, to do research for you, for my men to help you in learning. So that is it. Please, you can feel free to apply for the course here. The course starts on Tuesday next week. We already have like 50 participants, who are 50 something, I don't know. So we only need like 30 so that we get to commence the session. So this one is up for grabs as fast as possible. Other messaging platforms I use my LinkedIn. So yeah, my LinkedIn is there for you. So you can always text me on LinkedIn, and I try to respond to most of you. So feel free, my brothers and sisters. Feel free. If you have a project that you think we can work on, consultancy here and there, feel free to come to me. And we'll be actually having a graduation next week for the current cohort as well, for the cohort that just concluded their session on yesterday. And we are looking forward for another great session with you people. So this is the community for you. This is not about me. This is not about anyone. This is about you. This is about us. This is about us, my brothers and sisters. So join our community. Feel free, register for the course. I will try and see whether actually I can be able to say thank you to most of you who have been able to come to this session. Please, if you are registered, I have your contact and I keep it safe. I really don't share out your contacts. I never do that. We protect your integrity because you trust us with your phone number, you trust us with your email. So we don't expect us to share it out so that you can be spammed by anyone. That is our principle. I don't, and I will never sell my soul to anyone. I know most people have registered for our course. I will never sell your contacts to anyone. And that's the promise of Roundabout. And even my team knows that. So we'll never share it out. So always feel free to register for our programs. Feel free to come with us. We are creating a website. Oh my goodness. Let me show you that. I am here to show you a lot of good things today. www.ronshub, or just go to your Google and search. Let me see whether that is possible. Let me see whether that is possible. Just go and search. Let me open a new one. Okay, Ron's Hub, and just hit enter. And if you, oh no, not this one. just Ron's Hub, and you can see it will pop right here. So this is our new website, and you see this is us who are here. This is our beautiful team that is here. So you can get to interact with our website. We'll be having courses, and these are the testimonials for people that we've been able to train. So you can see this is my friend Latif Suboy. He is having actually a training in Ghana now on fast from 5th to 15 August. So we keep also in touch. These are good people from Kenya, from Somali, you know, from Zimbabwe, from different parts of the country that we've been able to train and impact. Yeah, this is my good friend Nathaniel Kanye. Ntaganda Moses, he came, we trained him, and he brought his brother Pacific, who has done a fantastic job. So this is our community. This is Elon Washira, another good engineer of ours. This is Yusuf. So feel free to join our community, check out our resources, enjoy. So that's it, my good people. Join our program. I am promising you for sure that I will commit all my resources, my energy to make you as good as possible. Yes, even if you're from whichever country, you can be able to pay. 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 Our payments are international, so you don't have to worry. You don't have to worry. Safe, secure, international payments. The cost is going for just 75 USD. 75 US dollars. I have seen courses going for 250 US dollars, 150 US dollars, 200 US dollars. We are not here to make money. We are here to impact the world, because that is our business in this place. So thank you very much. The meeting is adjourned. For the 47 who have been here waiting and listening to us, I am really, really honored. If I could be able to send a message to all of you that have been able to join our meeting here, I would do it, and I will try to do it. I have men who are very dedicated and able. They will send a message to you tomorrow to say thank you for attending this webinar. So thank you very much. We are looking forward to learn and grow with you. I will share the design, and I will also share the class recording. So thank you very much. Blessings. See you around. See you on Tuesday. See you on Tuesday as we do great things together. Thank you. And may you all have a good night for those who are sleeping. No, the training is online. We do it through Zoom, and it happens on Tuesday and Thursday. From 8 p.m., just the same time that you joined this program, up to the same time like now. Yes, we complete the program there. And then after the training, just like this one, I prepare short recordings for you so that you can be able to follow through the principles, so that you can be able to implement them at your own pace. The videos are 10 to 15 minutes. So if you watch one video per day, good. One video, good. One video, good. That's how you make it, my brothers. You will not wait and become good. Just start now. Join our program. Let's grow together. Join another team that is doing it. Ask them questions. Seek guidance. Submit your work for review. And this is what I say. It is better if you submit your work to James and he will give you bad feedback, other than you wait until you submit your work to your boss and your boss fires you. You know, the feedback from your boss, the criticism from your boss will be very harsh. For us, we are very kind. We attack while defending. Our feedback is meant to help you grow and learn. It's not meant to destroy your ego. You know, we're empathetic people. We give empathetic feedback. On Saturdays, you have a chance to do your presentation. I know engineers who have been working for the entire time of their, like they have been working for 10, 15 years. They have never earned a chance to do a project presentation, a professional project presentation. We are giving you that chance. You present your logical decisions, how you made decisions. Yeah. So join us, the training. Thank you. How do I contact you, David? Let me give you my contact. 2547456 34313. That is the Roundabout contact. You can text us on WhatsApp, and we will be able to respond to you, so you don't have to worry. I am actually the one who is going to respond to you personally. So yeah, you can text me on WhatsApp. You can text me on WhatsApp. My business is to talk to people. Let me write it. 2547 634 2547 45 313. Sorry, I was just confirming something here. So that is our WhatsApp number for the company. So we'll be able to respond to you immediately. So feel free to interact with us. We are here for you. We are here for you. We are here to help you learn and grow. Thank you, David. Text me now, and I will respond to you before I go to sleep. So thank you, everyone. Looking forward to a great time with you people. Yay, I'm seeing expert. Kenneth Rogoi, David, Mohammed, Anton Ochieno. Thank you, gentlemen. Wes, Dixon. Thank you to see you, my brother. Thank you. Thank you for showing up. Bernard Alego, always great to see you, senior. Paul Buana, thank you. Thank you. Thank you for showing up. Emmanuel Goza, thank you. Thank you, my brother. Thank you. John Gevenji, great. Dennis Derry, Latasha Ireri, Paul Buana, thank you. Thank you. Natasha again, thank you. Wesley, thank you. Thank you. Thank you, everyone. All right, the meeting is adjourned. The meeting is adjourned, and may you all have a fantastic night. Feel free to drop me a text. Thank you for your good wish messages, and see you around. See you around. Thank you. Blessings, blessings, blessings. Thank you.